now that we have a completed unit circle and we have it as a tool to sit in front of us, we can answer some basic questions like what is the cosine of 210 degrees? So look on your unit circle, locate 210, and what is the cosine of 210 degrees? The x value, which is going to be negative square root of 3 over 2. Good. What about the sine of negative 60 degrees? Now, because it's the sine, because it's negative, we go in the opposite direction. So let's go over to our unit circle. And 60 degrees, what's the sine at that location of 60? So this was what, 30, 60? What's the sine, which is the sine of theta is our y value, is going to be the negative square root of 3 over 2. So negative square root of 3 over 2. Okay, I'm going to write a few more of these down, and I want you to practice doing these. Tangent of 5 pi thirds. We come back 5 pi thirds right here. Tangent of that by our definitions are going to be what? The y value, this value, over the x value. So let's go back on the next page and write that down. So it's going to be negative square root of 3 over 2 divided by 1/2. We are going to algebraically simplify this by multiplying by the reciprocal. This cancels. Of course, everything in the bottom is going to reduce, and I'm just going to get negative, move that so you can see that negative square root of 3. Okay, we can extend these calculations to something like this as well. So if I have sine of 45 degrees times the cosine of 45 degrees. Okay, I'll give you a minute. Use your unit circle to put this value times this value, and then we'll calculate it. Great. The sine of 45 is the square root of 2 over 2. And you located cosine of 45, and the cosine of 45 is square root of 2 over 2. Now we just multiply those together. And we get, when you multiply square root of 2 times the square root of 2, we get 2. And then 2 times 2 in the bottom is 4. This simplifies to 1/2. Alright, the next one I want you to try is if you have the sine of 90 degrees plus the tangent of 45 degrees. Sine is 90 degrees is one of our quadrantal angles. What is the sine of 90? 1. Use your unit circle to identify. I'm just pulling over here. I come to 90 degrees. Sine of 90 is 1. Tangent of 45. 45 degrees is this. Tangent is my y value over my x value. But when you divide something by itself, by the same thing, you're just going to simplify to get 1. So 1 plus 1 is 2. Alright, our next example is cosecant of 45 times tangent of 60. Cosecant is going to be 1 over the y value. So let's just do some side work. 1 over the y value of 45 is going to be 1 over what? Square root of 2 over 2. Now I got to do some algebraic simplification here. So I multiply by the reciprocal. And then cancel what cancels in the bottom, and I get 2 square root of 2. Well, that needs to be rationalized, so I say times the square root of 2, and that becomes 2 square root of 2 over 2. And then one more time, I recognize that these 2's will reduce, and I have square root of 2. That means cosecant of 45 is going to be square root of 2. tangent of 60. Tangent is going to be your y over your x of 60 degrees. Tangent to your y over your x, and for 60 degrees it's square root of 3 over 2 times 1/2. We'll do some algebra here. Multiply by the reciprocal. And that would give us square root of 3. So that means tangent of 60 is equal to the square root of 3. So for our calculation, cosecant of 45 times tangent of 60, our calculated value for this answer is going to be square root of 6. Okay, let's see another example. Tangent of 45, locate that on your unit circle, cosine of 30. So tangent of 45, tangent is your y over your x, so tangent's going to simplify to be 1. And then cosine of 30 is going to be square root of 3 over 2 right there. So let's go back over here. So we said tangent of 45 simplified to be 1. Cosine of 30 is square root of 3 over 2. So the solution will be square root of 3 over 2. The next part of our notes is like use the calculator to approximate trig functions. Your calculator has buttons for sine, cosine, and tangent, or sine and cosine, but it does not have it for secant, cosecant, or cotangent. So only having a sine button and a cosine button, we have to be able to derive the rest of them. For secant, we know that secant's the reciprocal of cosine, so we would just put 1 over the cosine value. If you were using your calculator to determine the cosecant of theta, we would put 1 over the sine of theta. And cotangent, of course, is just the reciprocal of 1 over the tangent theta, or the x value divided by the y value. So write these down to be able to use them in the calculator. And then we're simply going to be just pushing buttons. Cosine of 48. Now your calculator needs to be in degree modes. This is wrong. Okay, it needs to be in degree modes regardless of that. So make sure it's in a degree. If it's not, there should be a mode button. Look for mode on your calculator, hit it, and change it to degree. And make sure that it's consistent. Cosine of 48, you should get this value. Cosecant, we don't have a cosecant button, so we have to put it in as 1 over the sine of 21, and we should get this value. And tangent, we'll have tangent of pi 12ths and be able to put it in. You have a pi button on your calculator as well. So this is not right. This should be in degree mode, I think, to be consistent with our values. And the very last thing we're going to do is we're going to talk about, I started today's lesson with giving you 6 trig functions defined with a radius 1. Now, if I tell you I give you a unit circle, we know the radius is 1. What if I give you a circle and I say the radius is 5 and I want you to answer these same type questions? Okay, the application to that is the 6 trig functions are defined with an R. If you look back to your the beginning of your notes, sine of theta we just said was y, but our radius was 1, so what is y over 1? Just y. So basically, you need to know these 6 trig functions for any radius, a circle with any radius, so you want to make sure you know these. You should be pretty comfortable with them because all day, all lesson, we worked on the unit circle and we just had an assumed radius 1. But these are the ones that you want to memorize for any given circle with possibly a different radius.